Hello everyone, my name is James and welcome to this tutorial on setting up the basic 2D platforming controls through C# inside of Unity. To begin this tutorial I've created two assets called floor and main character. Both of them are a 64 by 64 sprites and I'll just simply whop them out in Photoshop pretty quick. So let's drag this floor in, and this is going to be the main basis for our floor. Usually you'll use a tile sheet, but just here I'm going to create that and move it down. Perfect. Then I'm going to drag this main character in. You can see it has two derpy little eyes in there, just so we can see which direction the character's facing later on in the tutorial. So now if we hit play and let it run, nothing's happened. Nothing at all. And that's because all we've done is just added two images inside of a 2D but sort of 3D space. So what we're going to want to do is go to our main character, and we're going to want to add a rigid body 2D. This is the asset added to the character which allows for real-time physics. We're then going to want to freeze rotation, as we want the character to stay facing upwards at all times. Now let's add a Box Collider 2D. This is the asset which allows for detection of physics with other objects inside of the world, in terms of it creates a physical boundary which, when pressed against another collider, forces a collision onto the rigid body, which is pretty damn cool. And you'll see it a bit more on this one if we add it, Box Collider 2D. You can see a green line kind of facing around the edge of the mesh there. So now if we hit play, you'll watch it drop, and boom, collision. But we're not done yet. So if we go back to assets here, and I created a folder called scripts. It's very important to stay organized, so please keep your stuff in nice folders. Player movement is the code we're going to make. So let's go player movement, name it like that, boosh. And let's open it inside of Visual Studio. Okay, so this is where things are going to get slightly more complicated, but it'll be still easy to follow. In this tutorial we're not going to need start, so if we just delete that, and now we have a method called update and then a blank space here. So what we're going to want to do is we're going to create a public float variable, and we're going to call this hspeed. This stands for horizontal speed inside of the game world. We are then going to run a wire public rigid body 2D, make sure not to get confused with 3D, and name this RB. Okay, so now what we're doing here is we're creating a variable that can store the rigid body we've just added to our main character. Okay, so now in update, if we go here and we're going to write a small if statement that's going to check just to see what kind of key we're pressing, and in turn how the player should move in accordance to that input. So let's write if input dot get key code dot a. Okay, super simple. And now we're going to write left input. Okay, boosh boosh. Let's open up that, and then we're going to want to write rb dot velocity equals new vector2. Then open this up, and then it's going to be minus hspeed times by time dot delta time, and then rb dot velocity dot y. So now let me run this through with you, a little semicolon at the end so we don't get an error. What we're doing is we're checking, is the A key pressed? If it is, let's move with a new vector 2 on the rigid body to minus our hspeed value which we're setting, times by time dot delta time, and then we are not affecting the y at all. That just equals whatever it is. Doesn't matter to us in this instance. So let's copy this, go push push, change that value to right just so we know. If input.get key code D, because we're going to move to the right, and if we remove the minus, so we're now moving in positive values, do the exact same thing as we've done above. So if we hit play now, James, why ain't the code working? James, why ain't the code working? What you done? What you done wrong, mate? Unhit play. Go to your main character, actually drag the code to it, set this value to 400, And if we go to our rigid body, just get the rigid body off of the main character, or you can drag it from there to there. Let's hit play again. Boom. Movement. We have it. But you're not quite done yet. Let's go a bit more complex. As you can see, our character is always facing to the right, which isn't what we want. So let's change that. Let's go back into our code, and I'm going to write a little flag here, just so we know. Oh. Whoosh. Player movement. So we know that's like that. So now in our variables, we're going to write a public bool for boolean, and we're going to say facing right. So this is a boolean which we're going to use to track is facing right true, which means you're facing to the right, is facing right false, which means you're facing to the left. So let's create a new method that we can now call to. So public void facing, if I can spell it right method, open your brackets, open that bad boy with your squigglies, and here we go. So now let's check. In here we're actually going to check the velocity of x on our rigid body, and we're going to use that value to calculate if the player is facing to the right or facing to the left. Let's go if, not 9, Jesus. If rb.velocity.x is greater than 0, oh yeah, let's just do greater than for this case. Greater than 0, facing right is equal to true, which means if we're moving to the right in a positive value, you are facing right. And if we go else, oh, actually, it might be better to copy and paste that one and then just go, if it's less than 0, facing right equals false as you're moving to the left. And what this will do, the reason I didn't do it in a else statement is because what I want to do is keep the value when the velocity gets to 0. If I did do it in an else, as soon as the player stopped moving, it would automatically switch its direction to the left, and that isn't what we want. So that's cool. So we now have a method now which checks, sort of checks the direction and velocity of the player. So we can close that now, and if we go to here, calls to method, copy and paste the name we've set here, so facing right method there. That is then going to call it every single frame. Now this is a very key way of organising your code. Can you see how quickly I can just get rid of that? That's a fair few lines of code there. Boosh, gone, not visible anymore. Perfect. Okay? So now, what we're going to want to do is we're going to want to try and, I say try very loosely, because we are going to do it. We're going to try and organise the direction that the player is actually looking, because that's why I drew the little tiny stupid eyes on the mesh. So let's set one final variable, and let's call it public sprite renderer. That's the one. Character sprite. Okay, you can name it whatever you want. This last bit don't matter. I'm just calling it character sprite. Or actually, call it character sprite renderer. That'll probably be easier. Renderer. There we go. So now let's make a new method once again. This one is going to be public void awake, and we're going to say character sprite renderer is equal to get component, open that, and we're going to want to set it to the sprite renderer that this code is assigned to, which is our main character on the very load of the game. So as soon as you hit play, or as soon as we hit play in the editor, or as soon as they load the level, we are setting the character sprite renderer to get the component of the player that it's attached to, or whichever asset it's attached to into the game world. In this case, it is the player. And it's going to get that sprite renderer value, which it then changes the value of that. Which is cool. That's what we wanted. That's perfect. So now, let's check to see if we can change its direction. So we're going to ultimately use this facing right variables that we've set to do this. So if facing right is equal to true. Open up that if statement. We're going to say character sprite renderer right there at the bottom, cool, dot flip x is equal to false. So character sprite renderer dot flip x equals false. So let's not flip the sprite. Let's not have it look the other way. We're going to want it to look to the right. Else character sprite renderer dot flip x equals true. So now you're probably looking at this like, this is a code that's going to work. It's substantial, cool, you know. But we might be able to change it and make it more optimized. So let's add another if statement. So let's go if character sprite renderer dot flip x is equal to is not equal to false. Cool. Have it equal false. So this small line of code, although it looks relatively complex now that I've just moved it to there, it's all we're doing is we're saying only once we're doing this, whereas before we would have done it every frame. We're only doing this once. If the sprite renderer, which is that, if it's not flipped, so if you're not looking to the right, character sprite renderer dot flip x equals to false. So if you're not looking to, if that doesn't equal false, now equal false, and only do it once if facing right is equal to true. So now let's copy this. Actually, no, I only need this bit. Let's copy this. Thank you. Paste it right there. And this time we're going to want to say true. There you go. So now it's only going to do it once, which is that's just a nice bit of optimization there for you. This might look a bit confusing now that I've done the if statement differently. But if we just go like that, and I'll leave the other one exactly the same just so you can see. Boosh. It's the exact same thing. It's doing the same thing. So that's just calling into it in brackets there, and that's just doing it on the line after, which still works, which is perfect. So now if we hit play, here we go. The player works. As you can see, his eyes are moving both ways. You can run left and right, and that's perfect. See you in next week's video where we do jumping and we do hit detection with the ground to see if the player is grounded. And that's going to be a more complex one. Hopefully by then I won't have this cold so I can explain it a bit better. But we'll see what happens. Thank you very much for watching another James Lester tutorial. I'm going to be right back with you next week, messing around with Unity, firing about some C#, and seeing what we can come up with. So thank you very much for watching. See you next time.